Thank you. I always love it when I get, my first word draws applause. And I think it's all about how long you pause for afterward and just make people feel awkward. There's a presentation trick for you. So working at Microsoft and being focused mainly on Python, I was a Python developer before working at Microsoft. I have a number of embarrassing stories. I come out to these conferences and I'm known as the Windows guy. That's fine, I'll accept that. But I go back to Microsoft and there I'm known as the Python guy. Which means when Python stuff happens, I get to hear about it. So, and Microsoft's filled with a lot of very smart people, they know their computer systems well. And so it's a little embarrassing to have, directors of development hopping on IM late at night, just messaging me saying, I tried to pip install NumPy and it didn't work. How do I fix it? Or to go into a meeting with someone who's, there's about 1,000 levels of hierarchy. This guy was probably 3 levels down from CEO. Saying, my kids are learning Python. I had to spend 2 hours with them getting it set up on their machine last night. It's like, oh, ouch. And then every now and then, there's other teams at the company that want to use Python. And Microsoft is a Windows shop, big surprise. But some teams go, oh, we want to use Python. We'll run everything on Linux because it works better. That makes me sad. So why is Windows so broken? And what is the way to fix it? How do you deal with that? How do you get around it? But of course, the other question is, it's obvious why I do, but why should you care about Windows? Why would anyone who's not otherwise forced into it care about Windows at all? And there's a couple of reasons that I want to call out. It comes down to users, though. This is download stats, just rough approximation from the month of July from python.org. They don't compare very well. That top bar is the macOS downloads. macOS comes with Python. People get it from other places. That number doesn't matter. Next one is the source downloads. Most people can get the source from elsewhere. It doesn't count for much. But that last bar is downloads for Windows. Python.org is the main place people get Python for Windows, and that number is more than 4 million in 1 month. Over a year, that's 40, 50 million downloads of Python for Windows every year, annually. That's a lot of people getting and using Python. Windows has some of the best tools for using Python. This is just a sample of the IDEs that are available. Some of these are available on other platforms as well. But for users who get into the IDE space or get into the advanced tools, the advanced debuggers, the ones that let you step through C code and Python code, the ones that let you generate a whole lot of stuff and build it together really quickly, get attached to their IDEs. Visual Studio is obviously the one that I work on. People switch to Windows just so they can use Visual Studio. And that's why Python has to run on Windows. And a lot of people do real work on it. We took a survey a couple of years back, not from the Microsoft pool of people that we'd talk to. We went to other sources to find data scientists and say, what are you using? What are you running on? That biggest bar there is the people who are doing that development work on Windows. The bar below it is the people who end up deploying to Windows as their final target for their code. There are that many reasons why you need to care about Windows. Your code, no matter, unless it's completely in-house, is eventually going to be running on Windows somewhere. You need to be aware of it, you need to be ready for it. So there are 3 problems, 3 big problems, which all come out of those embarrassing stories I told earlier. Packages are hard to install, is the first one. We all know this, right? Everyone knows that packages don't install properly on Windows. And obviously it's because there's no compiler, right? Windows is client operating system first, even a server operating system, but it's not really a developer first operating system. It doesn't come with a compiler pre-installed, doesn't come with a complete dev tool chain by default, which means of the hundreds of millions of users who have Windows, also hundreds of millions of them don't have a compiler handy. But that's not the only problem. It's actually the culture. If you compare Windows to Linux, there's a very big culture difference as far as obtaining and using software. Linux and the ones prior to that are what I would call developer first. Developers are the first target of that operating system. They're going to have a compiler, they're going to have a toolchain, they're going to need it, And the source and the tools and the programs on those platforms are built around that idea. That whatever you're giving to someone to run on their machine, they will be able to compile it, and they will probably need to compile it because they've compiled something else themselves as well. Windows has a different culture to that, and always has. It's a binary operating system. It's a non-developer first operating system where people want to grab pre-compiled executables and just start running them. It's a totally different culture. It means you don't ship sources everywhere. It means closed source software is possible. Open source software is somewhat less relevant to a lot of mere users of the software because they're not interested in the source. They don't need it for anything. They want your executable files. They want something that they can just double click and run and actually make use of it. What this means for Python packages is when the ecosystem for Python packages builds up around shipping source code, particularly for extension modules, that doesn't fit the culture on Windows. There's a mismatch there. And you have all these Windows developers ending up with source, which may make perfect sense on Linux, and it doesn't make any sense at all for the Windows users. But once you get past not having the compiler, there are more issues. You have source code. Maybe, assuming your user on Windows has the compiler, your code may have other dependencies. It depends on other source files. Does the user have those? Maybe they do. They probably don't. Most Windows users don't have a big collection of source for other third-party libraries on their machine. So you need to worry about that distributing software by source on Windows, even once the compiler is there. You may have binary dependencies, things that your code assumes are available as part of the operating system that simply are not there on Windows. Doesn't matter whether the user has the compiler or not. People like to get stuck at that point. There's no compiler, it's all broken. Having a compiler will fix it all. Not if your code assumes that you can fork. Not if your code assumes that you have libuv. Not if your code assumes that everything behaves exactly the way that it does inside the Linux kernel. And then there's ABIs. Even if you have a built equivalent for that, even if you get past the source and binary dependencies, there will be mismatches. Compilers generate different code, calling conventions differ, the actual interface at the binary level is going to be different. And these three things combined, once you get past the compilers, lead to the problem of packaging not working well on Windows. People can't install extension modules, can't use your code. So here's the good news. The compilers are easy to get now. Over the last 2 or 3 years, we've made a lot of effort within Microsoft to get the compilers needed out there. I'll have links at the end. But you can now get the right compiler to build extension modules for Python 2.7, which includes 2.6 and 3.3.3.2 if you really want. You can easily get the compiler for 3.5 onwards. 3.3 and 3.4 is 2 extra steps on top of that, but we have info on how to do it. It's not a single click. But the compilers are no longer the blocking step. If at the worst case, you can tell your users, get the compiler, then you can install my package. But that's a worst case. Because it turns out that wheels are a really good culture fit. If you're not familiar with wheels, these are the packaging format for Python packages that include all of the built C extensions already. So one person, hopefully someone on the development team, has the compiler, has the source dependencies, has the binary dependencies, builds the package, bundles it into a wheel, marks it as this is Windows version. And again, the platform market for Windows is either 32-bit or 64-bit. There's no other variants to worry about. There are literally 2 platforms, and that will work Windows, Windows XP or Windows Vista up to the latest versions. So you've only got to do it twice for 2 Windows platforms, and then every single one of your users can pip install your package, get the wheel, and be up and going without needing a compiler, without needing a toolchain. I can see some careful faces who probably have packages that have other dependencies that they don't know how to ship in a wheel. You just need to provide more instructions for your users because you're doing something complicated, I'm afraid. Packages that have simple C extensions, accelerators along those lines that don't have extra third-party dependencies have a real easy time shipping in wheels. Continuous integration, sorry, go ahead.
So fundamentally, that's the wheels are the way to bridge the culture divide. Because yes, the core operating system is user-focused, but not to make it more developer platform, you just kind of add more and more wheels.
Yes, so the question is, are wheels the way to bridge the culture gap? Yes, they are. If you have wheels built for Windows for your package, you've bridged that gap. And maybe there's a few more setup instructions for users, but those instructions probably don't require becoming a developer. Continuous integration systems are catching up. AppVeyor, Visual Studio Team Services, there's a few other will let you build for free with some throttled thing on Windows to produce those wheels. You don't have to even have your own install of Windows to make these builds. You can do it all through continuous integration these days. And again, you only need one instance to make all of the different targets for Windows, because on a 64-bit machine, you can make the 32-bit package or the 64-bit package. And of course, distributions are available. As a user, when you need just all of the packages ready to go, a distribution like Anaconda, like Canopy, like WinPython, like Python XY, someone has gone and done all the work. Someone has built all of the packages. So as a data scientist who simply wants to use Python with all of its packages and NumPy and SciPy and scikit-learn and just have them work, those distros are often the way to go. If you're building up a web app from minimal stack and pulling in just the pieces you need, may not be the best starting point. They will work for that with a bit more complicated effort. But it is certainly a valid option, and it's what we generally recommend to users now. If you just want to be using Python with all of these packages, get Anaconda, install that, use that. And this came out today. For those who don't know Glyph, he helps maintain Twisted, which is one of the most complicated Python packages out there, very high performance networking stack. And he is announcing Python packaging is good now. Which people can laugh about, and he expects them to if you go read the blog. But over the last, considering that the history of Python packaging extends for over 10 years, over the last 2 or 3 years, with wheels, with continuous integration systems, with newer versions of pip, with better versions of setup tools, Python packaging is actually in a very good place. If you want to compare it to other languages that were invented 10, 20 years after Python and say that they have better packaging built in from the start, consider that Python had already made the mistakes that made those languages better. But Python's coming back around and catching up. A simple setup.py file will work for the vast majority of extensions these days. Did you have a question?
Yeah, I can ask you.
Okay. So that's packaging. It's not that bad. It's not that bad. And the way to fix it is wheels. The next problem. Python is hard to install, hard to launch, and insecure. Most people aren't even familiar with the third one. But that is the case, and some people have widely recognized that installing Python on Windows is actually a big security hole. To install Python on Windows, you've got to be an administrator. Now, for developers, this is not such a big deal. You're the only one on your machine. You have full control over it. Dialog pops up saying, do you really want to install this? And you say, yep, okay, and you go ahead and it's fine. Now you've got Python installed. But for a huge majority of users, especially on Windows, which includes students, which includes people in lockdown corporate environments, even some research institutions I'm aware of do not have administrator access to their own machine. You can't install Python on those machines. And that's a serious issue. That's seriously cutting out users of Python on Windows. It installs in system directories. It's actually going to put files in a system location where the system is meant to have their files. It's going right alongside kernel drivers on the file system, which is a really interesting idea. And a whole lot of security auditing software is going to say, hey, what are you doing? Please don't do that. This is not your directory. Go install somewhere else. The Windows registry, disliked by a lot of people who would rather just have one central configuration file, which I would argue is the registry. But if you don't use it properly, then you'll have collisions. Python, and especially older versions of other distros, are all going to try and write the same registry keys. That causes collisions. That causes problems. because they're going to look for their own settings information in a place where someone else has written it. It's bad. Even the 32-bit and 64-bit version of Python would override each other's registry settings, and so you couldn't have 32-bit and 64-bit at the same time on the same machine, which is a real problem. Messy path. Everyone likes having Python on their path, so you can just go to the terminal and type Python. I personally don't. And on Windows, this is actually a bigger issue than you may think. The path variable on Windows is not intended for your convenience at the console. It's intended for the operating system to find dynamically linked loaded libraries, which is why the system directory is first on that list. And if you put another directory before the system directory, you're now going to load dynamically linked DLLs from your directory instead of the system directory. That's going to break a whole lot of stuff. It's messy. There's also no central way of prioritizing items in this list apart from user intervention, manually editing. Last installed version of Python added to the path will be the one that you use, even if it's an older version. And it's insecure. Default location for the install is right in your root directory, which by default gets permissions, has write permissions for every single user on that system. So even if you install it as an administrator, if someone logs onto that machine as a guest, someone remotes into that machine from the network, someone somehow gets onto your machine, they can go and edit your Python files, including the standard library, including your site customize. They can put code in there that is going to run the next time you use Python without you knowing it. This is a really big issue, especially in multi-user environments. Again, developers not always in these environments, corporate users often in these environments.
Is that just because of the C drive or the 2.7 version? Is that what you're referencing?
So, spoiler. This is the good news. That was all Python 2.7. Would you like a reason to upgrade to 3.5? So Python 3.5 is when I took over the installer maintenance of CPython. First thing I did was go in and made a whole lot of fixes. So Python 3.5 on Windows, you can install without being an administrator.
Should be installed by default.
One little caveat to that is if your operating system is not fully up to date, you've got to update it, bring it up to date, and then you can install without being admin. You may have to be an admin to install the updates. One little caveat there. Anyone who's on Windows 10, which I think you have to pay for now, sorry, already has all the updates you need. So everyone on the latest version of Windows can install without being admin. Everything goes in the install directory. There's absolutely no point to go dropping Python into the system directory, so we stopped. There's no more registry collisions. So the first thing that I changed for 3.5 was to get the 32-bit registry separate from the 64-bit, no matter how you install it. So that collision is gone. The next thing was PEP 514, which you can go and look up if you're really interested in this. This is a registry format for all the distros to be able to have their own space to put registry settings. So it means that if you install Python 3.5 and you install the latest version of Anaconda and you install the latest version of, let's imagine another distro that's actually implemented this already, they're not going to stomp on each other. They're not going to override each other's entries. You'll have 3 distinct Pythons there. They can all be located. This is a big step forward as far as not destroying users' systems by installing Python too many times. The PY launcher, PEP 397, it's been around for a couple of versions, but this is how you deal with path on Windows. The PY launcher installs into a separate location that does go on path. The idea is that python.exe does not go on path, and you use py.exe instead. What this will do is scrape all of those registry entries, look in certain environment variables, look in a few configuration files, and map out all the versions of Python you have on your machine, and will either pick the latest version, pick the version that you've told it is the default, or it will look in your script file for a shebang line, including a Unix-style shebang line, find the matching version of Python on Windows and run with that. Which means if you have a script that should run on Python 3 on Unix and Python 3 on Windows, you can put shebang user bin Python 3, run it with the PY launcher on Windows, and it'll run with Python 3. And finally, a secure install directory, which is often pointed out is a much longer directory name than it used to be. With the PY launcher, that shouldn't matter. But the change there means that if you install for all users on the machine, if an administrator installs for all users, it will go in program files. Nobody can modify program files unless they're an administrator. If you install just for yourself, it goes in your user directory. No one can modify that except for you, which means you don't have to worry about people dropping extra files into your Python install anymore. And the third problem, in inverted quotes, isn't that guy cute? It might be deliberately scary, yeah. Python just works better on Linux. I mean, Python has always had a reputation for working well cross-platform, and it's incredibly well-deserved. Python has always worked really well on Windows, despite the fact that I don't think there's ever been more than 3 people actively trying to maintain or develop Python for Windows. There's about 20 core developers at the moment, 20, 30 core contributors. 3 of the active ones are listed as Windows experts. All the rest never touch Windows. Some of them are quite proud of that. Others acknowledge that it's not such a good thing that they don't touch Windows, but they don't have the time to pick it up and learn it. But despite that, Python's always been good on Windows, but better on Linux. And this is a problem because it gives people a reason to simply say, I will ignore Windows completely and focus on the platform that it's clearly designed for. And the reasons that it doesn't quite match. The compilers are not equivalent. On Linux, it's generally built with GCC. It has Clang support if you want to try and do that. I believe on macOS, it's not currently built with Clang for the official releases, but I think some of the ports that are available are built with Clang. On Windows, we build with the platform native compiler toolchain, Microsoft Visual C++, which has some slightly different behavior from other compilers. If you build Python with the Microsoft toolchain and want to build an extension with GCC, they're not going to be compatible directly. System calls are not universal. There are things that you can simply do on a Linux operating system that don't exist on Windows. There are things you can do on Windows that don't exist on Linux. And that means that you have some different functionality. If you're writing code that absolutely depends on one of those and won't work on the other, you've cut out a big chunk of potential customers, regardless of which direction you go. If you rely entirely on the authentication mechanisms that are available on Linux, they're not going to work on Windows. If you rely entirely on some of the net security stuff that's on Windows, it's not going to work on Linux. Python tries to bridge the gap as much as possible, but has to make compromises. And as a result, Linux tends to win those because of the greater bulk of developers contributing that. But as we saw earlier, a lot of Python developers or data scientists are developing on Windows and deploying to Linux. This needs confidence. You can't spend your time developing on one platform and hope to deploy it to another and have nothing change. You need to know that nothing's going to change. And as a result, when people are forced or required to deploy to Linux, they end up developing on Linux as well, so that they can be assured that everything that they write is going to behave the same in development as it does in test, as it does in production, which ends up being a problem for Windows because there are less people deploying to Windows despite the earlier graph. As a whole across the Python community, there are far more Python programs deployed to Linux than there are to Windows across the span of things. So the improvements here, the things that are already better and going to get better into the future. Python 3.5 uses a modern compiler. It has almost all C99 support. It has all of the header files that kept breaking stuff on earlier versions. I spent an hour at one sprint trying to get FFmpeg to build on the old compiler, and it was never going to happen. But on the latest, up-to-date Visual C++, it compiles just fine. And that's going to continue into the future. It's been set up this time so that you can keep using the most up-to-date compiler against Python 3.5 onwards and have the availability of the latest tools there. You're not locked into an old compiler. You're not locked into an incompatible compiler by virtue of what Python was built with. There are good libraries out there to hide the platform. I mentioned Twisted earlier. That is a great way to simply ignore what's going on under the hood. And it will give you the most performant networking on Windows and the most performant networking on Linux, despite them being implemented differently, because that's what the good libraries are for. Other libraries will equally layer over the syscalls that are involved and give you a nice clean API to work from while having libraries that are going to do the switching for the platform. And the big one, this is new. So I'm going to show you this one. All right, what happens next? What happens next? If I hit enter, who thinks we get an error message?
On my machine, you get
On a lot of machines, you'll get an error message. So this is not Sigwin. This is not any layer. Well, it's not any user mode layer that you may have seen before. It's not MinGW. This is a complete Linux distribution. To prove it, I will show you that it does in fact have Python installed, and it is an old version. This is not something that Microsoft has put together as much as enabled. This is a full Ubuntu distribution installed, running on Windows. You can see I'm still within the same command prompt. I haven't jumped out into anything at all. And no matter who you ask, it's proper Linux, running on Windows. If you want to develop, if you need to verify your code on Linux but want to be developing with those awesome tools I showed earlier, this is the way you can do it. This is the way to validate code running on Linux without having to switch to another machine, without having to deal with SSH and all the interesting behaviors of some of the clients on various platforms. This is local Linux. It is, in fact, it even has full NTFS access to my current drive, including write mode, which I don't know who we paid to do that, but we made that work. So that's available now. This is, to get this, I will have a link up in a sec, but this is the latest update for Windows 10, which is available now. Can you edit the save password file? I have not tried. Let's chat afterwards.
I doubt it.
I hope not. Okay, I have links coming up. Get cameras ready, because I'm going to leave it on this last slide so that you can find all of this stuff later. Windows has a reputation for being broken with Python. It is not well-deserved anymore. A few years ago, it was absolutely well-deserved. Packaging was a mess. Installation was a mess. Security was a mess. Compatibility was a mess. Now, if Python is still a mess on Windows for you, part of the problem is that you're still using 2.7. Part of the reason is you're not using one of the distros that includes 2.7 that have improved a number of these things. But the future of Python on Windows, it's Python 3.5 and onwards, is looking very bright, much more stable, much more secure, much more compatible, and much more well-supported from all directions, industry, and community. Thank you for coming. My name's Steve Dower. Happy to take questions.
The Linux on Windows, is that a performant thing, or is that really not for production, more for testing?
So the question is Linux for Windows is it performant, essentially? Is it meant for production or is it meant for testing? At the moment, it's very much meant for testing. Performance-wise, there are certainly some performance benchmarks online. Quite a few people have gone in and done it. The one that the team behind it mentioned to me was, what were they compiling? They compiled something with GCC, and it was like a 1.3 times slowdown compared to being on a native box. So it's very close to having Linux on a native box. The way that it works, like I say, it's not a user mode shim, it's a kernel mode shim. Every time that Linux makes a syscall, that gets intercepted, transformed into a Windows kernel call, and is fulfilled by the Windows kernel. But every binary is an ELF binary. There's been no modifications. That Ubuntu is the same Ubuntu that you would get if you installed it from the same distro on a different machine. The only difference is the kernel internally has been swapped out for mappings to the Windows kernel. Yes?
What's the difference between like a compiler and a compiler for Python?
So the difference between a compiler and a compiler for Python is absolutely nothing. These links are version numbered with the Python version. So VC Python 2.7 is the compiler for Python 2.7. VC Python 3.5 is the compiler for 3.5. The version numbers of the compilers are different. So internally, the first one is version 9, the other one is version 14. If you don't know what that means, it's not very helpful. So I made links that have the Python version number in there. But in fact, the one for 2.7 was a special release for Python 2.7. So that one's labeled for Python 2.7 because it's an old deprecated compiler that we want to get rid of, but everyone still needs it, so we got it out there specifically for Python developers. Yes?
Do you think people are going to use Linux on Windows as an excuse not to distribute their Windows packages?
So I'm a little concerned. Do I think that people are going to, like package developers are going to tell their users, I'll just use Linux on Windows so I don't have to build my package? I suspect there'll be some of that. And this may be the reason that it's not being, that we're actively not telling people, hey, go use this in production right now. I suspect that there's going to be some incompatibilities. There's going to be some vague differences there that are still, that, you know, we're probably down to 0.1% incompatible as opposed to 90% incompatible. But I don't know that, until those are ironed out, I don't think people will be completely confident running that in production yet. And so there's still going to be a need for people locked into Windows Server who are not able to use the containerization support to run a Linux container in there yet, who are still going to want to be deploying on Windows natively. There's also a number of packages that people want to use, and again, I get questions about these all the time, that people want to be using on their clients. And so I think there's always going to be a demand for packages on Windows. What we really hope that the Linux support will enable is people will be able to have, so rather than being in an alternative operating system where maybe you have 90% full POSIX compatibility and a lot of edge cases, they can be on Windows and have close to 100% POSIX compatibility through this option. It's going to be more integrated over time and will be, we hope, a very good development environment, combining and really blurring the lines between the Windows part of the OS and the Linux part of the OS. But we certainly hope that for developers, it will enable living on Windows for a lot of the time and being able to run the code on Linux without leaving that OS at all.
So just as a follow-up, do you see that becoming the default way of installing Python sometime?
Do I see the Linux on Windows being the default way to install Python? I don't think it will. But I am still not sure yet. I'm looking for really good suggestions on how to make the Windows version of Python so much better than the Linux one that people will want to use it anyway. And I have a few ideas on things that we can do with Python on Windows to make it so much better on Windows that if you are using Windows, you'll want to stay there. But again, certainly for some people, it will become the alternative, and some people will switch to it. That's great.
How about making a Fortran compiler available?
Both the NumPy developers are in the room.
SciPy.
Oh, SciPy, sorry.
That's the main. It all comes down to this every single time. You have like all the internet, website, e-commerce people, blah 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 blah, and then there are the data scientists or computational. And all we really want is SciPy, and we just can't get it unless we use Conda or Christoph.
Yeah. Christoph's site, why doesn't Microsoft have their own managed precompiled? Works on Windows, great. Where's that? I mean, if a guy at UCI can do it.
Just for the video, can I get you to repeat the question, please?
Is Microsoft going to do something like pre-compiled packages on Windows?
That would be awesome.
That's going to get snipped out and sent up my management chain.
Because Intel's doing that now, right? They're shipping SciPy, but it's these guys. Evidently, who knew?
Yeah, certainly there's a lot of interest in in fully built distributions of Python for Windows, including a lot of packages. There's definite value in that. Certainly the last that I heard from the guys at Continuum, the guys at Enthought, is they ship many, many, many more copies for Windows than they do for other platforms. And I would assume that that's still the case. There is, so to get to this series of questions, Fortran compiler is probably unlikely to come from us. As I understand from chatting with a lot of the NumPy guys and a lot of the SciPy guys, the biggest concern with the best available compiler on Windows right now, which is the Intel one, would likely also be a concern if Microsoft did one, because I can't see us releasing it in a GPL compatible way because we tend not to do that. So that's unlikely to actually solve the problem. Intel's one, I understand, is difficult to, well, is not a single-click download to get hold of. And that, again, this is probably a case where the main reason people need the Fortran compiler is for developing the Fortran code. Simultaneously, I also hear that the reason we don't just deprecate the Fortran code and replace it with C code is because it's unmaintainable. So, given those two... So I've been told that the two choices are either, for high-performance linear algebra, is either inline assembly or Fortran code. I would argue that out-of-line assembly is also an option, and that's totally supported by all the compilers that you like, including the assembler. So I would disagree, but that's a separate conversation to have. That is not one of the main flaws with Windows right now, and in fact, I think this is something where the Linux command line will make a big difference for people who want to develop that and are on Windows, because as I've said in previous discussions with people, a lot of this is very platform agnostic, especially the NumPy and SciPy side of things. So developing that code and tuning it on Linux is not going to hurt significantly when you port it to Windows, compared to something like, say, Twisted, where the entire thing is native API calls, and you can't validate that on Linux and expect it to just work the same on Windows.
So what about then, I mean, if not a Fortran compiler, make these libraries similar to what the MKL or AMD MapCore or whoever develops, make them available on Windows. Like, could there be a Windows version of MinPack or LePack or any of those?
Yeah, so essentially could Windows ship a BLAST library? And yes, it could. Those libraries are a very big investment, and for Microsoft to go off and invest in that is certainly a business decision that's outside of my pay grade as far as allocating resources and saying, let's do this and give it away for free. That's not our business model. As you may be aware, Microsoft makes money from selling software, as opposed to companies that give you software and also ads. Though I think we're getting into that as well because, hey, it's lucrative. It means we can give you more software.
Does PyPy factor in any way, or is PyPy, what's your perspective on PyPy and Windows?
Which PyPy?
So, yeah, PyPy, pronounced PyPy, as opposed to PyPI. Does it factor in on Windows? I mean, it certainly does. It's not currently as well supported on Windows as other platforms. We have not been hearing from the people we interact with a huge demand for it, is really what it comes down to. There's certainly a few very keen people who would love it to be fully supported on Windows, but for the people that are coming to us and saying we have huge bags of money in our back pocket, we really want PyPy support, they just aren't doing that.
Do you have any insider perspective you can share publicly about PyPy? It seems stalled to me.
I actually have very little interaction with the PyPy development team from either of my hats, either at Microsoft or CPython. So I can't comment on where PyPy is at these days.
What about IronPython or PythonNet?
So IronPython I am a little more familiar with because I'm still on the mailing list for that. Microsoft obviously got rid of IronPython many years ago, and it became a community project that's been led by a very busy person working at Amazon. He has recently passed on leadership of IronPython to some other people who claim to have more time, so expect more development there. I believe they're getting another alpha ready and looking at adding Python 3 support or finishing their Python 3 support very soon. which I believe is going to be 3.4 compatible, possibly only 3.5. I'm not sure exactly what they're targeting there. But IronPython development is back on, and it certainly still gets used. I keep running into people who are genuinely using IronPython in production frequently, depending upon it. It's far from dead. It's not the most supported, most active distribution of Python out there. But again, considering the ecosystem of Python distributions other than CPython, or Python implementations other than CPython, it's not doing too bad.
Can you talk about Visual Studio Code? Is that, because it had Python bindings and all that, how does that play with Python tools? And is there plans for Visual Studio Code to integrate into things other than Git, like TFS?
So I have some interaction with Visual Studio. So the questions about Visual Studio Code, where is that at? Where is it going? As far as Python support, there's a great community extension which has largely borrowed from the support we wrote for Visual Studio, and that works great by all accounts. And so we're actively telling people, go get this extension. We are looking to contribute into that and enhance a few things based on our experience with Visual Studio. So over time, I'd expect to see IntelliSense get better, debugging get better, and hopefully some more interactive modes show up in Visual Studio Code. As for other aspects of VS Code, I'm not part of the core development team on that, so I don't know what their future plans are. But the general plan is for it to be very extensible. So if you can't currently get an extension to change source control provider or change the target for your source control, I would assume that something will be coming soon or will be available in that sense. If there's no other questions, I will be around for the next couple of hours. Feel free to come and chat. Otherwise, enjoy your lunch. Thank you.